Hello, so today we're going to learn about our parallelogram theorems. And a parallelogram is a quadrilateral shape, so a four-sided shape, where opposite sides are parallel. Just like this one here. So the first theorem that we have to learn about parallelograms just states that opposite sides are equal and opposite angles are equal. So in this parallelogram here, if we label that A, B, C, D, that would mean that the distance from A to B is equal to the opposite distance, which is D to C. And we can similarly say that our distance from A to D should be the same as our distance from B to C. Again, the reasoning why is because both of these sides are opposite, and opposite sides must be equal. This theorem also tells us that opposite angles must be equal in measure. So an example of this would be our angles A and our angle C here. So because they're opposite, we know they're equal in measure. So the angle DAB, which we can see here, going from D to A to B, should have the same measure as its opposite angle, DCB. So what I'd like for you to do now is to go to your notes and fill in next to Theorem 9 a small diagram showing that opposite sides of a parallelogram are equal and opposite angles of a parallelogram are also equal. And you can pause the video while you do that, and when you're ready to continue, just press play. So now we move on to the first converse to Theorem 9, which just says that for any quadrilateral or any four-sided shape, if opposite angles are equal, like for example the angle A and C, then this shape must be a parallelogram. So for example here, if the angle BAC has a measure that's equal to the angle DCB, again these are both opposite angles, so BAC is opposite to DCB. If those opposite angles are equal, then this shape is a parallelogram. Again, you can pause the video here and just take down some notes into the section next to Theorem 9, Converse 1. Again, you can pause the video now, and when you're ready to go on to the next section of this video, just press play. So now we're on to the second converse to Theorem 9, and this one is related to side lengths. And it just says that for any quadrilateral, if opposite sides are equal, so AB is equal to DC and AD is equal to BC, then this shape must be a parallelogram. Again, if you'd like to pause here to take down notes next to your section on Theorem 9 Converse 2, this is the time to do it. And when you're ready to move on to the next section, just press play again. So now we're on to the corollary to Theorem 9, which just says that any diagonal which divides a parallelogram will split it up into two congruent triangles. So an example of this will be in this parallelogram here. We already know, because we're given that it's a parallelogram, with both sides being parallel to each other, that any diagonal that is drawn across this, so for example from B to C, although it could go from A to C, this diagonal is going to split up the shape ABCD into two congruent triangles, which means that it has the same shape and same size. This is particularly useful for us now because we know that the angles inside in these triangles are the same for both triangles now, ABD and CDB. So for example, this angle here is congruent to this angle, and this angle here is congruent to this angle here. And of course, as we know, our opposite angles of the parallelogram are also equal in value. So again, if you'd like to pause the video here, this would be a good time to do it. Take down some notes on your corollary to theorem 9, and then when you're ready, you can press play again to bring you through to the next theorem. Okay, so now we're on to theorem 10. In theorem 10, again here, we're given a parallelogram. And theorem 10 just says that if you draw a set of diagonals across your parallelogram, that those diagonals will bisect each other, which means cut each other in half. So that means the line going from D to B will cut in half the line going from A to C. And the line going from A to C will cut in half the line going from D to B. So again, this line from A to C is cut into two equal segments, and the line from B to D is also cut into two equal segments by our two diagonal bisectors. So I'd like you to pause the video here and take down your notes for theorem 10. And when you're ready, just press play again. So now we're on to theorem 17. Theorem 17 just states that for any given parallelogram, like this one here, ABCD, if we draw any diagonal, I'm going to draw a diagonal from B to D. This diagonal will divide the area of the parallelogram into two equal sections. So what that means for us is that the area of the triangle ABD is going to be equal to the area of the other triangle that forms, which is BCD. Again, this diagonal here is going to split the parallelogram up into two triangles of equal area. So I'll shade both of those different triangles now. Again, the area in green there is going to be equal to the area in yellow. So if you'd like to pause the video now, and it's time for you to take down a couple of small notes into your handout on your parallelogram theorems. And when you're ready, you can just press play again. There's one more theorem left to get through. So now we're on to our final parallelogram theorem. We're almost there. And this one, again, just relates to the area of the parallelogram. So this theorem allows us to find the total area of a parallelogram. And to do that, all you have to do is multiply the parallelogram's base by its height. Now, a common mistake that people can make here is multiplying two side lengths, so BC times AD. You have to be very careful that you're multiplying its base by its perpendicular height. So I'll show you an example of that now. If we have a parallelogram here, ABCD, and the base has a total length of 8 centimeters, and the perpendicular height up along here is 7 centimeters from the top to the bottom. Then in order to calculate the area, we just multiply the base by the height. So in this case, the base is 8, the height is 7. So our total answer is 56, and our unit, of course, for area is going to be squared, so centimeters squared. Again, make sure that you have the notes from this down into your handout, because I will be checking it in the next lesson. And if you have any questions, please just send me a message on Schoology.